Hey, this is Jason Clark here again at South Dakota State University. Welcome to our webinar series on nitrogen rate recommendations. In this video, we'll be talking about our soil test nitrogen credit and our yield goal fertilizer recommendations. So to this point in our video series, we've talked about how we determine yield goal, how we then multiply it by 1.2 coefficient and what that coefficient is. The third step, which we'll cover in this video, is subtracting those two values from our soil test nitrogen value. When we're determining our soil test nitrogen value, we head out to the field, and here you can see a cross-section of the field, and those white dots represent nitrogen fertilizer in our soil. So we go out to our field ready to test that soil. We take out our soil probe, and then we go down our first depth. We go down that 0 to 6 inch depth, which is where we measure phosphorus, potassium, sulfur, organic matter, CEC capacity, and things of that nature. However, we can see that there's still a lot of nitrogen that's just below that 6 inch depth that's going to be accessible by those corn roots, especially since nitrogen is mobile and moves to the corn through the water. So we're not only going to take that 0 to 6 inch soil depth, we're also going to take a 6 to 24 inch soil sample. The next thing we're going to do is put each of these soil samples in a bucket, mix them up well, and send them to the lab. And then from there we're going to get back from the lab how much soil nitrate is in each of those depths. So 0 to 6 inch depth and the 6 to 24 inch depth. We're going to take that 28 pounds of nitrogen in the topsoil, 30 pounds of nitrogen in the 6 to 24 inch depth, and we're going to add it together. And that 58 pounds of nitrogen per acre is going to be our soil test nitrogen we use in our equation. In these sites here, the SDSU long-term mean, if you don't take a soil sample, put 40 pounds of nitrogen per acre, is on this blue line. And these red lines are what we actually saw in each of these fields, which had quite a high range, 25 to 92 pounds per acre. And if we look at the mean of these sites, we actually see an increase from that 40 to actually around 56 pounds of nitrogen per acre. But even using this mean, we can see how sometimes we're underestimating how much nitrogen is in there, such as our 92, and we're overestimating how much is in there, such as our 25 pounds per acre. So this really shows that we really need to test our soil to really know how much nitrogen we should credit in this yield goal equation. So if we look at our recommendations versus what we actually needed, so we take that recommendation, subtract it from the optimal nitrogen rate, we get this red line right here. This is without that soil nitrogen credit. The closer to 0, the more accurate we are. So if we use that credit into play and subtract that nitrogen value, we want to see if our estimates become closer to that 0 line. And we can see in the majority of these sites, if not actually every single one, that blue line is closer to 0 than the red line, showing a more accurate recommendation when we add soil test nitrogen. It actually reduces the amount we're overestimating our fertilizer recommendations by 56 pounds of nitrogen per acre on average. So again, we see the importance of using and getting soil test nitrogen in our recommendation system. So again, for a review, have our yield goal, multiply that by our 1.2 coefficient, then we subtract our soil test nitrogen with 58 pounds of nitrogen per acre in our example, and next up is our legume credit. So stay tuned for that segment of our video series. Again, thank you for your time, and as always, check us out on social media to stay up to date on our research and any other topics of interest.